Good morning, students. Welcome to the Aryabhatta PU Science College. Now we are switched on to the 8th period of the second chapter. Derive an expression for energy stored in a capacitor. In the previous class, you have studied about the capacitors connected in series, connected in parallel. Now we are going to study what is the energy stored in this capacitor. Here is a positive plate and here is a negative plate. In between the plates, potential is there. How much energy is stored, that we have to study. This how much energy stored is used in some materials, that is in the choke. You see the bike. In a bike, if the vehicle can't start, then what we will do? We press the button of the choke. Then afterwards, if we start the bike, then automatically the bike will start. So in that way, for that uses the capacitors are used. So for this, the energy, what is the energy stored in the capacitor, that is always needed for this. You see, what is the derive an expression for energy stored in a capacitor. So plus here is the plates. This is positive plate, this is negative plate. So consider the following. C is equal to capacitance of the capacitor. C is equal to capacitance of the capacitor. Plus Q is equal to charge on the positive plate. Plus Q is equal to charge on the plate. Minus Q is equal to charge on the negative plate. Minus Q is equal to charge on negative plate. V is equal to potential difference across the plate. V is equal to potential difference across the plate. And W is equal to total work done. W is equal to total work done to transfer all these negative charges to the positive plate. W is equal to total work done to transfer all charges from negative plate to the positive plate. So work done means transfer all these charges from negative plate to the positive plate. This is the work done. And U is equal to W. U is equal to energy. Work done to transfer all these charges to the positive plate is nothing but energy stored. This is energy. How much energy is stored to transfer this here to this plate. So that is the energy, total work done to transfer all these charges from negative plate to the positive plate is nothing but energy stored in the capacitor. W is equal to U is equal to W is equal to energy stored in the capacitor. And dq is equal to extra charge. This is the extra charge is there. Suppose this is an extra charge. This extra charge is a dq, and we have to bring these charges to here to this plate, from negative plate to the positive plate. Then dw means very small work done. For small charges, a small work is done to transfer these charges dq from negative plate to the positive plate. So this is here. dw is equal to work done to extra charge from negative plate to the positive plate. From negative plate to the positive plate, there is a dw is the work done. So dw is equal to V into dq. We know this formula. dw work done, small work done is equal to V into potential into dq. That is small charge, this one. So C, but we know C is equal to Q by V, which means V is equal to Q by C, cross multiplication, and also for further cross multiplication, Q is equal to CV. C is equal to QV, cross multiply this, Q is equal to CV, and again we want V, so transfer this C to here, and it comes denominator Q by C. Q by C is there. So that's it. So dw is equal to Q by C into dq. For here dw is there, we have to know. So V is Q by C. Put this Q by C into this equation. This we get Q by C into dq. dw is equal to Q by C into dq. So that is and the total work, W is equal to total work. This dq is only small charges bring from this point to this. We have to bring all these charges from this to positive plate. That is total work done, W. capital W. Capital W is equal to total work done from 0 to Q charges. How many charges are there? Q number of charges are there here. To bring a Q number of charges from negative plate to the positive plate, extra work is done. So that is 0. 0 means no charges to all the charges. All the charges we have to bring from 0 to Q. So that is Q. So that is 0 Q by C into dQ. Here dW means Q by C into dQ. So put Q by C into dQ instead of dW. So Q by C. 1 by C is common, taken outside. So Q into dQ remaining. Q means integration of Q is Q square by 2. That is formula is there. Integration of Q is Q square by 2 and 0 to Q. So lower limit to upper limit. So the one C is there and put Q for Q. Both are same here. So that is put Q into this Q, that is Q square. 1 Q square by 2 minus lower limit. Lower limit is 0. For Q you have to put 0. 0 by 2. So that is 0 by 2 it becomes 0. Remaining is 1 by C into Q square by 2. So but Q is equal to CV. Q is equal to CV. You know this. Put this into the here. So Q by C, Q square means Q C square V square by C. 1 C cancels. So remaining is U is equal to 1 by 2 into CV square. So this is an expression for energy stored in the capacitor. Once again I am explaining from this. So dW is equal to work done to extra charge from negative plate to the positive plate. So dW is equal to V into dQ. C is equal to Q by V. We know this. So cross multiplication this Q is equal to CV, and if you transfer this C to this here, and Q by C is equal to V. So dW is equal to V instead of V we have to put Q by C. So Q by C into dQ. So integration dW means W is equal to 0 to Q dW. So dW means in the arc work done. So dW means Q by C into dQ. So dQ, and 1 by C is equal to Q into dQ. So dQ means so the integration of Q is Q square by 2 0 to Q limits. So upper limit minus lower limit apply. 1 by C is common. First you have to Q to this Q square by 2 minus here Q means 0 square by 2. First is upper limit and next one is lower limit. So this becomes 0. So 1 by C into Q square by C. So Q is equal to, but Q is equal to CV. We know this. So Q square means Q square V square by C. 1 C Q square cancel. So what remaining is 1 C. So half CV square. This is an expression for energy stored in the capacitor. This is very important. It comes in March 16th, 17th and 20. And in the previous period, capacitors in series, capacitors in parallel. And this question, this is a set of questions. So repeatedly they are asking in the examination. So you have to learn it well. All this you have to take it in a notes and in the rough. By seeing one time, without seeing another time, you have to write it in the rough. Next, what mention the uses of capacitors. So capacitors are used. Choke in vehicle, you know, choke. If you press, if the vehicle does not start. So if you press the choke, then automatically the bike will start. That is choke. Lighter, you say lighter, cigarette lighters or stove in cooking. If we on the lighter, then it will start. The fire catches. So lighter. Mosquito bat, I have shown the mosquito bat. So if you press the button and if you just touch the mosquitoes will smash. So that is mosquito bat. So these two it is a familiar example. Another in the textbook these examples are given. Either you can write any in the examination. To store electric charges. So first used. Second one, to store electrical energy. And third one, as a filters in electrical and to four-wheelers, we can see this filter. As a potential divider is used in this, in some circuits in TVs. Radio and TV circuits for tuning. Tuning means the sound is maximum or minimum. To make a sound maximum or minimum, these capacitors are used. Generation and detection of electromagnetic waves. Electromagnetic waves, we will see this in the 7th chapter. What is electromagnetic waves? How to generate electromagnetic waves, that we have to see. You can see in this capacitors are used. And mosquito bat, lighter and choke in vehicles. These are the uses of capacitors. And write all this in a notes. And this derivation is very important. By seeing one time, without seeing another time, you have to write it in a rough. Okay, best of luck.